Hello, my name is Christoph Wichmann, and in this video I would like to explain how you can use the Axway API management solution with the OAuth Pkce flow, which is an extension to the OAuth authorization code flow. The use case is the following: that you have a backend application that is expecting an access token from a trusted third-party authorization server, and the Axway API management solution should act on behalf of the resource owner, which is basically the user on the left-hand side, using any sort of user agent. And when using the standard authorization code flow, the following happens: that the user agent is performing on behalf, of course, of the user an API call. The first thing, the API management solution is now checking if it already has an access token for that resource owner, performing a lookup to the local token store. If there is no access token, then the Axway API management solution starts the OAuth dance by redirecting the user to the trusted third-party authorization server. And this communication is now, let's say, not part, or the Axway API management solution does not play any role in that login and also in that authorization. So that means the user logs in with some sort of way, it then authorize the Axway API management solution to act on behalf of the user. And finally, it comes back part of the authorization code flow with that callback, and that callback contains the authorization code. And that authorization code can then be used to exchange it into the real access token. And the access token is then stored based on that user and can be used in subsequent calls as long as the access token is valid, and it's also supporting refresh tokens when hitting the backend on behalf of that user. So the difference now to the Pkce flow is that the redirect, or that the authorization request is not containing the client ID in secret. Instead, it contains the client ID and the challenge. And this challenge is created by the client initiating the authorization request. And the code challenge is based on something which is called the code verifier. So that means we are performing that redirect, including a code challenge. That code challenge then is stored on the authorization server in combination with the authorization request. And when the token should be exchanged, then this code verifier the code challenge was based on needs to be transmitted in order to get the token. And with that, the authorization server knows that this authorization request is based that this token exchange request is based on the authorization request. To avoid that someone can just get the authorization code and use it to exchange it into a real access token. So how this can be configured on the Axway API management solution. For the demo here, I have used Keycloak, and I have just configured the demo environment, and I have configured a single client application which I call test app, and this is the client ID. And also I have configured this application to only support, or to support Pkce, and only with that challenge method. So that means the code challenge needs to follow that standard, which we do. And with that configured, you cannot obtain an access token any longer using the standard authorization code flow, because you have to provide a proper code challenge. So, and on the gateway side, the configuration starts pretty the same as for standard authorization code flow. You go and configure under external connections, client credentials, OAuth. You configure the API gateway basically to be a client application to the third-party authorization server. That's why I have configured with my provider settings, my Keycloak, with the authorization endpoint, with the token endpoint. These are basically the general settings. Of course, there's also, let's say, local token storage and so on. And the more important thing is then on the individual applications that are registered on the authorization server. So here you see it's the same as for the authorization code flow. Even the flow type is authorization code flow because there is no Pkce. The difference now is that we do not need to provide a client secret because this is not required. And we only have to provide the client ID to kick off that flow. The redirect URL is also required for the Pkce flow, and I have defined that the callback for that application should be keycloak/callback. And this is used by the API gateway when creating the redirect location header. That redirect URL is sent to the authorization server because I expect the callback to come back to me at this location. The most important thing in order to enable Pkce is here under the advanced section, where you define that 3 additional properties, which will then be sent with every authorization request and with every token exchange request. So we send the code challenge, we send the code verifier, and we send the code challenge method. Of course, we will not send the code verifier for the authorization request because that makes no sense. But you will see how this is configured using the policy, using custom policies. So that's all you have to do. And depending on your authorization server, you may have to configure other details like where to find the client credentials and so on. So, and now let's have a look at the policies. And I have configured that policies here, OAuth client, keycloak, and everything starts with the keycloak backend policy. So this is simulating a backend that is expecting an access token. And in my case, I have just mocked this. So that means when I have a proper access token, we are following that path. And then there's just a mocked response. So as the X token should be stored, should be retrieved on behalf of the user, you have to find a way to authenticate the user based on a session cookie, based on an ID token, based on classical authentication. You have to set the authentication subject ID. In my case, I just hard coded it to Chris because it's not, let's say, in the scope of this video to explain the different options how users can be authenticated or how that resource owner can be obtained. When the resource owner is known, we are trying to look up the access token for that resource owner. So that's why this is the resource owner and this is the Keycloak application you saw before. And if there is an access token, then we are just passing the request to the backend, including the access token. If there is no access token, then we are starting the Pkce flow. And for that, we are creating that code challenge, which is a scripting filter. And this script filter is creating the code verifier on which the code challenge is based on. Here it is by intention added to the whiteboard as code verifier key, as I don't want to have it for the authorization request sent along with that. So that means I used by intention a different name for the attribute. But then here, maybe at this point more important, that we are adding the code challenge. And the code challenge is, of course, based on the code verifier. And we are also putting the code challenge method according to the standard. And with that, attributes placed on the whiteboard, we can now redirect the user to the authorization server. So, and now that attributes are added to the request because they are configured for our client application. The next thing we have to do is to make sure that the code verifier can be used and is reused when the user comes back from the with the callback. So that means we are using, or I'm using that OAuth state, which has been created randomly for that authorization request. And that OAuth state based on the standard is returned from the authorization server on the callback. And that's why it's a link between the authorization request and the callback request. So as the state is not added automatically to the whiteboard, I'm using a script filter to get it from the generated location header. And finally, I put it as an extra attribute to the whiteboard with the name state. All these filters are documented. I will explain where you can find that. And lastly is then to put that verifier key you saw in the scripting filter using the attribute state into a local cache I have configured. So, and when now the client comes back, when the user has authenticated and authorized the application, um, he is redirected to the callback URL we have defined. And here again, we need to know who is the resource owner, because the access token should be stored on behalf of that resource owner. We are getting the OAuth state, which is just a simple extract REST request attributes, and I do care about the query string parameters because the state is part of the query string. And now we are using that state parameter to obtain the code verifier, which we have just saved before in our local cache. And now as this attribute is known and placed on the whiteboard, I can go and I can now go and exchange the authorization code to an access token using again that configured client application. And as this client application had the code verifier included, now the code verifier, as expected by the standard, is sent along with the token exchange request. So let's close all this. And finally, for convenience reasons, we are redirecting the user agent to the requested backend. Of course, that you can implement this dynamic using also cache it or whatever. In my case, I just put it static. So, and now let's see how that looks like in action. So, and firstly, I'm going to remove any existing token from my API Gateway local token storage. And I'm using a private browser window to say, I would like to call that backend, which is supposed to be protected by an access token required from Keycloak. So now I have been redirected to the authorization server. So when looking into the API gateway, I see that there is that backend call and we are redirected. So we define the resource owner, which is Chris, and then it is identified that there is no access token for the resource owner Chris in the local token storage. That's why we are following the red path and creating a code challenge with the code verifier, and then we are redirecting the resource owner to the authorization server, including that code challenge. And then we get the state, and we store that code verifier together with the state and the cache. And here's the location header, and that header now contains our code challenge method. It also contains an empty attribute code verifier, but that's okay, it works. And we have the code challenge itself, which has been generated. And now the authorization server is storing the authorization request together with the code challenge. So now let's complete the authorization request. And normally you get a challenge and everything, and to accept the authorization, all that normal OAuth dance. But as I have already authorized the application, this does not appear again. So let's see what happens now. We receive the callback. We get the resource owner. This is just that simulated that user Chris is has been identified. Now we are getting the state. We obtain using that state from the we are obtaining the code verifier from the cache, and then we are exchanging the authorization code. We received here I made a mistake, but we received the access token. So that means let's have a look for the incoming request. So this is the callback where we have received the same state which we have sent. And this is the authorization code we have received, which should be exchanged to the access token. And this is the call we made to now, or this is the call the API gateway made to obtain to obtain the access token. So this is the token endpoint we have configured with our client application. And here we are adding now the code verifier together with the authorization code. And only with that code verifier given, we are getting an access token from Keycloak. So that also works, of course, for Azure AD and for other authorization servers, as it is following the Pkce standard flow. And now, of course, if you are requesting that backend API a second time, then the flow is a little bit more simple. You see there is no callback, nothing, because now we can retrieve the access token from the token storage based on the user Chris. And that's why we have access to the backend. And that backend will not show us the token because I have not configured it in a way, but yeah, it works that exactly that way. That's basically all I wanted to show. You can find all that information on that GitHub repository and also with the scripting filter, and so that you can easily copy and paste them into your policies if you would like to use it or if you need to use it. Thanks for watching. I hope it was helpful, and bye-bye.